Yeah, welcome back. So in this video, what we are going to study about? We are going to study about null space. Then we will discuss AB equals to 0. If matrix A multiply with matrix B and it is giving you 0 result, then what you can conclude about matrix A and B. And then we will see some questions. Okay, so this will be the flow of this video. Now I hope you are studying right from the beginning. You must have started with rank, then you have studied about a system of linear equation, then vector space, and now we are going to study about null space. So there should be a complete flow. Please don't study the discrete topic, this video, that video. Please study right from the beginning. Okay, so now we are going to study about null space, but before that you will answer two simple questions. What questions I am asking? That are vector 1 to 1 0 0 0 independent of each other? Are these two vectors, let's just say this vector is vector A and this vector is vector B, are they independent of each other? So what is the method that I told you? That make a matrix C and write down these vectors in row form or column form. Let's just say I am writing down in row form. So I have written in the row form. Is it in the row echelon form? Yes, sir. What is the rank of C? Rank of C is coming out to be 1. What does that mean? That means there is only one linearly independent vector. Or you can say one linearly independent, that means other one would be dependent. So one linearly dependent vector. Say yes or no? That means they are not independent of each other, no? So only one is linearly independent, other one is depending. And you can directly see here that vector B is nothing but 0 times of vector A. So this guy is depending on this one, no? Sorry, this one is depending on this one. B is 0 times of A. And what is B? B is a null vector. Similarly, if I ask the same question here, what you will do? Sir, 1 2 0 0. Again the same scenario, sir. Rank is coming out to be 1. Again, sir, one linearly independent vector. And sir, one linearly dependent vector. What does that mean? That means this vector B was again 0 times of A. So are they independent of each other? No. Are they independent of each other? No. Now let us say I make 100 sets like this. 100 sets like this. Okay, I am making 100 sets. Here some element is written A, B, C, D, I don't know, whatever that is written. And the length is also 100 only. Okay. The length is also pretty big. And I am making 100 set. One of the vector is all 0. Now I am asking you a question. Is this set of vector, is this space linearly independent? What I am saying is that this vector and this vector is linearly independent. This vector is also linearly independent. So I am having 100 dimensional 100 vectors. What I am saying? I am having a 100 dimensional 100 vectors. And out of these 100 vectors, I don't know about 99 vectors. I have no information of 99 vectors, but I know about one vector which is all 0. This vector is all 0. Only one vector I know. Now I am asking whether this particular set is linearly dependent or independent. You will say, sir, even if I don't know about 99 vectors, still I can say that it will be linearly dependent only. Why is that so? Because it is having all 0. And this particular vector will surely depend on other vectors. Because if, like this, some vector is vector A, if you multiply vector A with 0, you will get all 0 vector. If some vector is vector B, if you multiply that vector with 0, then you will get this 0 vector again. So what does that mean? That means all 0 vector or a null vector can never be linearly independent. Is that clear to you? Because if all zeros are present, that means it will be surely depending on someone else. So this is the statement that we need to write down, that a null vector can never be linearly independent. That's it. A null vector can never be linearly independent. Sir, why this point? I will be using this point somewhere else. Okay, so that's why a basic discussion I wanted to do about the null vector, that null vector can never be linearly independent. It will be surely depending on something. Okay, let's study about the null space. What do you mean by null space? So let's just say I am having a matrix A. You are matrix A. Okay, you are matrix A. You are having a matrix A. Now some vector x came and he got multiplied with this matrix A. And the final result that you got was null matrix. What was the scenario? You are having a matrix A. Okay, some vector x came. Now what this matrix did? This matrix A got multiplied with vector x and eventually gave you the result 0. So what this x is known as? So x is known as, the vector x is belonging to the null space of vector A. You will understand in a great detail, but as of now we are just looking at the definition. What was the scenario? There was a matrix A, the vector x came. The vector x came, that means it could be having a order of n cross 1. and let's just say this is having a order of m cross n. So m cross n, n cross 1. So now this vector x came, it got multiplied with the matrix A, the final result came out to be 0. Then what is the language we are going to use? The vector x is known to be belonging to the null space of matrix A. Vector x belongs to the null space of matrix A. Null space. This is the null matrix you are getting, no? So what does that mean? That means that this matrix A is mapping this vector x to 0. Again, this matrix A is mapping this vector x to 0. So this matrix A is like a machine and this vector x is like your haters. Okay, so you are that machine and some haters is passing the comment. So those comments came, you listen to those comments, and then the final output is 0. That means I am not being affected by those comments. So you are having a matrix A, you are the matrix A. This is a machine. This is a machine. In the machine you gave some input, you gave the input of vector x. At the output you are receiving 0 output. Whatever that came, at the output you received nothing. 0 you received. Right? What does that mean? This vector x belongs to the null space of matrix A, or you can say this matrix A is mapping the this matrix A is mapping the vector x to 0. Matrix A is mapping the matrix A is mapping the vector x to null or to 0. Is that clear to you? So this is the language that has been written here. We take a matrix A, multiply it by a vector x. If the result is 0 vector, then x belongs to the null space of A. Hence, the null space is a set of all vectors that are mapped to 0 by matrix A. Vector x is mapped to 0 by matrix A. Understandable? Let's understand the example and you will be able to understand in a better manner. So matrix A is given. You need to find out that this vector and this vector belongs to the null space of A or not. This is something that you need to find out. Understandable? So what we will do? We will multiply our matrix A with the vector x and we will see the result. So what is our matrix A? Sir, this is our matrix A. 1, 2, 3, 2, 4, 6 and 3, 6, 9. This is being multiplied with -2, 1 and 0. Let me know what is the result you will be getting. 1 multiplied with -2, -2. 2 multiplied with 1, 1. 3 multiplied with 0, 0. 2 multiplied with -2, -4. 4 multiplied with 4, 4 multiplied with 1, 4. 4 plus 4 minus 4, 0. 6 multiplied with 0, 0. Similarly, -6 plus 6, 0. There you go. So when your vector x, let's call this as vector x1. Okay, I'm calling this vector as x1, or let's not call it x1. What should we call it? Let's call it as v1. Okay, and let's call this vector as v2. So when I multiplied vector a with v1, what I am getting? 0. That means v1 belongs to the null space of A. Understandable? Similarly, if I do other thing, I am taking vector v2 this time, which is -3, 0, 1. So what is the result I will be getting? 1, 2, 3, 2, 4, 6, 3, 6, 9. If I multiply -3, 0, 3, 0, -6, 0, 6, 0, -9, 0, 9, 0. So when I multiplied vector v2 with matrix A, the result I am getting is null. What does that mean? Vector v2 belongs to the null space of A. Understandable? So yeah, this question has been done, but let's see what we can conclude from these problems. Now the question that I am asking, that are there only two vector possible like that? What I mean to say is that if I am multiplying any vector, let's just say some v alpha vector with A, so can I get 0 again? This is my question. Two vectors has been written. Are there other possible vectors as well? Yes sir, directly I can sense one thing. What I can sense, let's just say sir, you take this example only, and what you do, here you have written -2, 1, 0, right? What you have written? -2, 1, 0. Instead of this, what you do, multiply this with 3, 3 and 3. What you are getting? -6, 3 and 0. So here you write down -6, 3 and 0. -6, 3 and 0. Again you will get 0, 0, 0 result only. Why is that so? Because what is -6, 3 and 0? What is this? -6, 3 and 0 is the same thing. It is nothing but the same thing. It is simply minus 2 1 0 only, minus 2 1 0 only, with 3 getting outward. 3 is a constant value. So this is being multiplied with this matrix. So what you get? Minus 2 1, in place of minus 2 you will get minus 3, in place of 1 you will get, sorry, in place of minus 2 you will get minus 6, in place of 1 you will get 3, in place of 0 you will get 0. So both are the same thing only, no? What I mean to say is that if I say b into a, or if I say a into b equals to 0, then for sure a into 3b will also be equals to 0, no? Do you understand this point? Because if 3 comes outward, it will become 3 into ab equals to 0, which shows ab equals to 0 only. Are you able to understand this point? So what I am saying is that if vector v1 is a null space, if v1 belongs to the null space, then alpha v1 also belongs to the null space. Say yes or no? Along with that, if v2 belongs to the null space, similar thing, if v2 belongs to the null space, then beta v2 will also belong to the null space. Say yes or no? What does that mean? What you are saying? You are saying that, sir, first I got to know that a into v1 is coming out to be 0. From there I concluded that alpha into a v1 will also come out to be 0. Or better you write down a into alpha v1. A into alpha v1 will also come out to be 0. Or what you can say, alpha into a v1 will also come out to be 0. And similarly, sir, when I got to know that a into v2 is also coming out to be 0, so a into beta v2 will also come out to be 0. Or you can say beta goes outward, a into v2 will also come out to be 0. Understandable? Another thing you can conclude from here, just look at these equations. Which equations? These two equations. If this is the scenario, let's take it here. If this is the scenario that a into alpha v1 equals to 0 and a into beta v2 equals to 0, then what you do is that you add up both of these equations. What you do? You add up both of these equations. A into alpha v1 plus a into beta v2, that would be equals to 0. If I take a common, a I am taking common, so what I am getting? Alpha v1 plus beta v2 equals to 0. What do you understand from this equation? I hope you are getting this point. If a into v1 is 0, then a into alpha v1 will also be equals to 0. So what does that mean? That means if v1 belongs to the null space, then alpha v1 also belongs to the null space. If v2 belongs to the null space, then beta v2 also belongs to the null space. Now if I add both of these equations, then this is something that I am getting. What I am getting? A into alpha v1 plus beta v2. What do you understand from here? From here I can conclude that alpha v1 plus beta v2 also belongs to the null space. Say yes or no? So can you write down the null space? Null space means, what is the meaning of space here? Can you write down the null space? Space means set of vectors. I told you in the last lecture only. What is the meaning of vector space? Vector space means set of vectors. So can you write down the set of vectors which will make the matrix, which will be mapped to 0 by matrix A? Can you write down the set of vectors which will be mapped to 0 by matrix A? Yes, sir. First vector we have find out is minus 2 1 0. Then we find out minus 3 0 1. First we find out minus 2 1 0. Then sir we find out minus 3 0 1. In the similar manner, sir, let's just say I multiply this matrix with 2, so it will become minus 0 6 2. So this will also be one of the element of null space. Sir, if I multiply this matrix with 3, so what I will get? Minus 6 2 0. This will also be one of the element. And sir, what if I do? What if I take the linear combination of both of them? Let's just say multiply this with 3 and multiply this matrix with 3 and multiply this matrix with 4. So what I will be getting? Multiplying this with 3 will be minus 6 3 0, plus multiplying this with 4 will be minus 12 0 and 4. So what you will be getting? Minus 18 3 4. Minus 18 3 and 4, both of them added, right? Simply I am taking 3v1 plus 4v2. This is what I have done. So minus 6, 4, 12, minus 18, 3 and 4, yes. And in that manner, infinite elements would be there. Say yes or no. In that manner, infinite elements would be there. Infinite elements would be there. So how many elements? Infinite vectors would be there. Infinite vectors would be present. But out of those infinite vectors, you will have only two linearly independent vectors. Are they linearly independent? Say yes or no. Are they linearly independent? V1 and V2. Are they linearly independent? Yes, sir. V1 and V2 are linearly independent. And apart from that, none of them is linearly independent. Here you can say that, sir, this is simply 2 times of V2. This is simply 3 times of V1. And what was this? This was 3 times of V1 plus 2 plus 4 times of V2. So all are basically what kind of vector space you are having? V1, then V2, then 2V2, 3V1, 3V1 plus 4V2. In that manner, 2V2 plus 2V2 plus 3V1 and so on. These kind of vectors you will have. So you will have maximum 2 linearly independent vectors. 2 linearly independent vectors only. So in the null space, in the null space of A, in the null space of A, you will have only 2 linearly independent vectors. So now I am asking you a question. First question. Okay, listen to the question very carefully and give me the answer. If I ask you first question, how many such vectors are possible which will be mapped to 0 by matrix A? Again, how many such vectors are possible which will be mapped to 0 by matrix A? You will say, sir, infinite vectors are possible. Second question, how many such linearly independent vectors are possible which will be mapped to 0 by matrix A? How many such linearly independent vectors are possible which will be mapped to 0 by matrix A? You will say, sir, only 2 vectors are possible. But here the doubt would be rising that sir, how did you conclude only 2 are possible? So that we will see. Okay, so that is our matter of discussion, that how only 2 are possible. It might happen that only 1 is possible. Yeah, another doubt would be that, sir, if I multiply this matrix A with 0 0 0, if I multiply this matrix A with 0 0 0, then I will get 0. So sir, why 0 0 0 is not a element of vector space? What I mean to say is that, sir, why you are not writing 0 0 0 here? Here 0 0 0 may also come, no? Yes, 0 0 0 will come, for sure it will come. But is it linearly independent? No, it is not linearly independent, no. 0 0 0 will always be linearly dependent. First slide, can never be independent. So 0 0 0 will always belong to the null space of A. It will always belong. But we will never consider it. We will never talk about it. We will never talk about 0 0 0. So next lecture will be about eigenvector and eigenvalue. There also we will never consider about 0 0 0. Because the reason is that 0 0 0 is never linearly independent. I don't care about these infinite vectors. I only care about 2 linearly independent vectors. I only care about these two guys. Do I care about all those infinite vectors? No. My matter of concern are only V1 and V2 because they are linearly independent. Rest all are depending on them. So even 0 0 0 will also depend. Let's just say here I write down another vector which is 0 vector itself. So this guy is also depending, no? So do I care about this guy? No. Is that clear to you? So that's why this first slide was there, that 0 0 0 will always be a dependent vector. So no matter a multiply with x will give you 0, and if this vector is 0 itself, then surely you will get 0 only, but you will never care about it. Why we will never care about it? Because 0 0 0 will always form a set of linearly dependent vectors. I only care about the number of linearly independent vectors. Now the task would be that, sir, how do I find out the number of linearly independent vectors? Can you think about it or not? Let's try thinking about it. What was our equation? Ax equals to 0. This is our scenario, no? If this is the scenario, then you can say that x belongs to the null space of A. Say yes or no? Right? Understandable? Ax equals to 0. Have you seen this equation somewhere? Yes, sir. It will have unique solution, or it can have infinite solution. What is the condition of having unique solution? Condition of having unique solution is that rank of A should be equal to the number of variables. Rank of A should be less than the number of variables. If it is having a unique solution, do you already know the solution? Yes, sir. What is the solution? If it is having a unique solution, then sir, I already know the solution. The solution will turn out to be 0, 0, 0. And if it is having infinite solution, then sir, infinite solutions are possible here. 0, 0, 0 will also be a solution, and other solutions are also possible. One more thing I am asking you, can you comment about the number of linearly independent solutions? What I am asking, number of linearly independent solution of A, number of linearly independent solution of matrix A, or what is the other name? The other name is number of free variables. That would be equal to the nullity of A. Very, very, very important conclusion that we have already seen. And this will come in this case only, no? Because in this case you already know the solution, which is 0, 0, 0, 0 only. So here there is no free variable. All the variables are 0. But here there might be some free variables. They will comment on the number of independent solutions of number of independent solution of Ax equals to 0. Right? Now let's see if I needed to find out the null space of this matrix A. Now what is the question? The question is that matrix A is given, and find out the null space of this matrix A. Now this is our question. So how will I do it? So that we are going to check out. What is the question given? The question is that this is your matrix A, find out its null space. Find out null space. Okay. And then second question, in the null space, find out the dimension of null space. Then find out the span of null space. Find out the span of null space. Span of null space. What do you understand by span of null space? What is the meaning of span of null space? Span of vector space. What is the meaning of span of vector space? In that vector space, how many linearly independent vectors you are having? That means how many linearly independent vectors you will have in the null space of A. Do you understand this point? In the null space, whatever the null space that you are getting, how many linearly independent vectors you will have? So if I am saying that I am having 2 linearly independent vectors, what does that mean? That means what will be its span? Its span will be 2D, right? Its span will be 2D. So here can I write down that null space belongs to R3 with some condition. Why is that so? Because if it is belonging to R3, then its span would be 3D. But if its span is 2D, then there would be some condition, and based on that condition you are getting 2D span. How you can say 2D span? Because there are only 2 linearly independent vectors. This we have understood in the last lecture. In the vector space, if I am having only 2 linearly independent vectors, what does that mean? That means the span will be 2D, right? So if there is a 2D span for R3, that means there would have been some condition, because otherwise if it was directly R3, then the span would have been 3D. But if the span is 2D, then there would have been some condition, no? So let's check out what kind of condition we are having. Let's check out everything. Understandable? So what we need to find out? We need to find out its null space. Let X be a null space. Null space, and one of the vector would be somewhat like this: x1, x2, x3. Now you know that Ax would be equals to 0. x1, x2, x3. That should give me 0, 0, 0. What is the matrix? 1, 2, 3, 2, 4, 6, 3, 6, 9. Can you write down the equation from here? x1 plus 2x2 plus 3x3, x1 plus 2x2 plus 3x3 equals to 0. 2x1 plus 4x2 plus 6x3 equals to 0. 3x1 plus 6x2 plus 9x3 equals to 0. If you look closely, if I take 2 common from here, what I am getting? x1 plus 2x2 plus 3x3 equals to 0. If you look closely, if I take 3 common from here, what I am getting? x1 plus 2x2 plus 3x3 equals to 0. So effectively, this was your equation 1, this was your equation 2, and this was your equation 3. Effectively, all these three equations combined was only one equation. Although there were 3 equations given, but actually there was only one equation. What was the only one equation? Only one linearly independent equation you were having. The equation was nothing but x1 plus 2x2 plus 3x3 equals to 0. This was the only equation you were having. So what you can say, sir, 3 variables but one equation. What does that mean? 2 free variables you have. So what I can conclude is that, let's just say x3 is c1 and x2 is c2. Then what will be your x1? X1 will be nothing but, sir, x1 is nothing but minus x2 minus x3. Sorry, x1 is nothing but minus 2x2 plus 3x3. So sorry, it could be written as minus 2 c2 minus 3 c1. Is that clear to you? So x3 is c1, x2 is c2, and x1 is minus 2 c2 minus 3 c1. Is that clear to you? So how I can write down my solution vector? x1, x2, x3. The solution vector will look somewhat like this. Minus 2, or first write down minus 3 c1 minus 2 c2. Then you write down c2, then you write down c1. Now can this vector be represented in this manner? c1 into minus 3 c1, then 0 and then 1, plus c2 into what you need, minus 3 c1 minus 2 c2, then 1 and 0. Is that clear to you? If you multiply this c1 with c1 here, what you are getting? Minus 3 c1 plus 0, minus 3 c1, then 0 and then c1. So minus 3 c1 minus 2 c2, minus 3 c1 minus 2 c2. c2, here only c2 you are having, so c1 into 0 will be 0, c2 into 1 will be c2, and here c1 into 1, c2 into 0 will be c1 only. So this is how you can write down, and these two are your v1 and v2. This is your v1 and this is your v2. How you can write down about x? What you can say? Sir, my vector x is nothing but R3. What is the meaning of R3? 3-dimensional vector, all coefficient will be real with the condition. What is the condition? The condition is that x1 is nothing but minus 2x2 minus 3x3. Is that clear to you or not? Is this line clear to you or not? I am defining, let's just say I am defining the vector set, the vector space x. What I am defining? I am defining vector space x like the previous video. Sir, my vector space x is given by x1, x2, x3 belonging to R3 with the condition that x1 plus 2x2 plus 3x3 should be equals to 0. Now if I ask you what is its span, what will be your answer? What is the span? What you will say? This is the question. Forget about everything, whatever that we have studied. Forget about everything. If this is the question that I am asking you, let me know the span. What will be your answer? Sir, what will be the span? Sir, I will say, okay, R3, that means, sir, 3-dimensional span would be there. But, sir, on one of the variable, they have put up the condition. What variable? I can say that, sir, x1 is given as minus 2x2 minus 3x3. So, on one variable, they have put up the condition. That means, effectively, I thought that they are 3 variables, but effectively, they have become only 2 variables. So, I can get 2 linearly independent vectors. So, my span will be 2D. And what is the meaning of 2D span? That you can get 2 linearly independent vectors. So those are your 2 linearly independent vectors. Rest all the vectors will be depending on them. So from here, what you can conclude? That I can have 2 linearly independent vectors in the span of null space. Or what I can say? I can say that the span of null space is 2D, or I can say I will have 2 linearly independent vectors in the null space of A. Is that clear? Now the question is, what nullity of A would represent? What I am asking, what nullity of A would represent? Think about it. Nullity of A represents, what nullity of A represents? If Ax equals to 0, if your equation is Ax equals to 0, in this equation, what nullity of A would represent? What is this? Nullity of A. So what nullity of A represents? Nullity of A represents the number of free solutions, number of free variables, right? Or what is it represent? Number of independent solutions. Independent solutions of Ax equals to 0. So here, how many number of independent solutions you are getting? 2. Number of independent solution, 2 free variables. Yeah, this is the condition. 2 free variables you are having. 2 free variables you are having. If I was having 2 free variables, then how many independent vectors I was having? 2 independent vectors I was having. If I was having 2 free variables, then I was having 2 independent vectors. It is pretty obvious, no? You will be having 2 independent vectors. So what do you understand from here? You can understand that nullity of A would represent the number of free variables or number of independent solution of Ax equals to 0, or number of independent vectors, number of independent vectors in the null space which is X of matrix A. Or what you can say, it will represent the dimension of span of null space of matrix A. What is the meaning of dimension of span of? Basically, if I ask you what is the span of a space, what if I ask you what is the span of a space? So you will say, sir, it is 2D span. The span is 2D. That means what is the dimension of the span? If I am asking you what is the span? What is the span of R3? What you will say, sir? 3D. The span is 3 dimension, no? Or what I can ask you? What is the dimension? What is the dimension of the span of R3? So answer would be 3. What is the dimension of the span of R3? So answer would be 3. So usually we write down span is 3D. So if someone asks you what is the span? Span is 3. No, the actual word would be the span is 3 dimensional. Or what I can say, the dimension of the span is 3. 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 Understandable? So dimension of the span of null space is equals to the nullity of A. In language, sometimes this is the correct language, no? But sometimes in the language, in the examination, what they will ask, dimension of null space. So this question would be given in the examination. Find out that dimension of null space. So what you will do, sir, directly I will calculate the nullity of A. Matrix A would be given, okay? Matrix A would be given. What would be given? Matrix A would be given. They will ask you what is the dimension of null space. So simply you need to calculate the nullity. And this is how this topic is taught, that matrix A is given, they are asking the dimension of null space. What you need to do? Calculate the nullity. This is what people remember. But this is the whole actual concept. Everything regarding the discussion of null space in one question only. So shall we understand everything right from scratch? What we started with the basic definition of null space. Null space means it is a set of all the vectors. It is set of all the vectors which will be mapped to 0 by matrix A. What is null space? Space means set of vectors. So it is the set of all the vectors which will be mapped to 0 by matrix A. Understandable? You are listening to the words very carefully. Then I give you the question and I am asking you whether they belong to the null space of A or not. Then you multiply them and you go to know that yes sir, 0 answer I am getting. Surely they belong to the null space of A. Then I asked you one more question. What if I multiply this with 3 or this with 2 or this with 5 or this with 7? Then also I will get the answer to be 0 only. That means those vectors, if I call this as V1, this as V2, then 5v1 will also belong to the null space, 7v2 will also belong to the null space, and 5v1 plus 7v2 will also belong to the null space only, right? So these many vectors will belong to the null space. So there will be infinite vectors like that which will belong to the null space, but there will be only two linearly independent vectors. Now sir, for this particular question, how you can conclude that there will be only two linearly independent vectors? There could be three as well, there could be only one, there will not be only one because we have already written two. So who knows, there could be three as well. So what we did, we tried finding out the null space of this. When we tried finding out the null space of this, what we got to know that effectively there was only one equation, that means there will be two free variables. And can you find out the rank of this A? What will be the rank of A? You can directly see that, sir, this will be doubled, right? And this will be tripled, this will become 0, this will become 0. So rank of A is 1. And what is the nullity of A? Nullity of A is number of variables, which is 3 minus 1. So nullity of A is coming out to be 2. So what we got to know that there are two free variables and one dependent variable. So two free variables x2, x3 are free. x2 is x2 only, x3 is x3 only, but x1 is depending on x2 and x3. And if I ask you that x is belonging to r cube or x is belonging to r3, x is belonging to r3, but there is a condition on x1 that x1 is twice of x2 and plus thrice of x3 and then multiply with the negative sign, then what you will say, sir, effectively there is only two variables. Effectively, if there are only two directions, that means my span will be 2D. So what is the dimension of my span? The dimension of my span is 2D. And how I can calculate? By simply calculating the nullity, because nullity represents the number of free variable and number of free variable represents the number of independent solution, and that will represent the number of independent vectors in the null space. Say yes or no, put a like. Okay, put a like. It is very necessary because you pick 10 lectures of engineering mathematics, no matter from whichever the sources, they are not going to teach you in that manner. This is the complete intuition, right from zero to everything, whatever that is required. Is that clear or not? Okay. And one more conclusion we can see, if it is a full rank matrix, if there is a unique solution, then what will be the nullity of A? So nullity of A will be 0. Nullity of A will be 0. So from here, what you will be able to conclude, that means the null space will only have one vector, and that vector will be nothing but 0, 0 and 0. This is what you will be able to conclude. But here in this null space, you may have infinite vectors, but out of those infinite vectors, how many of them will be linearly independent, that you will be able to calculate by finding the nullity of A. Is that clear to you or not? Complete discussion is, sir, absolutely crystal clear, to the point. Say yes or no. That's it. This is the whole point. We can solve the questions now. Find out the null space of A. What you will do? Sir, I know one thing. Ax should be equals to 0. First, can you let me know how many linearly independent vectors would be there in the null space of A? How many linearly independent vectors would be there in the null space of A? So for that, what I can do? I can calculate the nullity of A. Nullity of A directly rank of A is directly coming out to be 1. And nullity of A will be number of variables. It is 2 cross 2. So number of columns are 2. Number of variables minus 1. So nullity of A is coming out to be 1. That means in the null space, I will have one linearly independent vectors. That means dimension, that means span of null space. Span of null space would be what? What will be the span of null space? So sir, span of null space would be nothing but 1D. Okay, and you will check that there will be only one free variable. How we can check it? Directly we can check it. That, sir, this is very simple. x1, x2 multiply with 0. So from here, sir, 2x1 plus 4x2 equals to 0 minus x1 minus 2x2 equals to 0. Sir, effectively they are only one equation. They feel like two equations. Effectively they are only one equation. If I take minus common from here, what I will be getting? x1 plus 2x2 equals to 0. If I take 2 common from here, what I am getting? x1 plus 2x2 equals to 0. From here this equation I got. From here this equation I got. So sir, effectively they are only one equation. What does that mean? If I say my x2 is c1, then what will be my x1? If my x2 is c1, then sir, x1 will be nothing but minus 2c1. So what is my x1, x2? So x1, x2 is nothing but this will be minus 2c1 and this will be c1. So x1, x2 is coming out to be c1. I can take common. This is minus 2, 1. So this will be your one linearly independent vector. So if I talk about the null space, then the null space would look somewhat like this. In the null space, you will have these elements minus 2, 1, Then let's do the half of it. If I do the half of it, what I will get? Minus 1 and 0.5. Let's do the thrice of it. What I will get? Minus 3, 1.5, and so on. Along with that, 0, 0 will also be one of the element, right? So in that manner, a lot of elements we will have, but only one linearly independent vector I will have. What does that mean? What will be the span here? What will be the span? Span will be 1D. In the language, what they can say? This is the language dimension of null space. So what will be the dimension of null space? If they ask you dimension of null space, so they may write dimension of null space, but what they actually mean to ask? If in the examination dimension of null space is written, although this is not a good question, no? Dimension of null space. What do you understand by dimension of null space? Dimension of span of null space. Dimension of span of null space. But when they are saying null space, by default I will consider span of null space. Okay, span of null space. Okay, so dimension of null space if they are saying, then simply what you need to do, nullity of A, that will be equals to 1. So I hope the concept is crystal clear right from 0, and what that vector would be, that vector would be minus 2, 1. Understandable? Okay. So basically this value will be twice of this value multiplied with the negative sign. Understandable? So yeah, let's solve next question. Null space of A. Again I need to find out the null space, right? So can you find out the null space? It will come out to be 0, 0, 0, I guess. What I try to do is that first let's find out the nullity of A. What I'm trying to do, I'm trying to find out the nullity of A. This is the first thing that I'm trying to do. So what I will have to do, I will have to find out the rank, because this matrix feels like that it will give me 3 rank only. Okay, what it will give me? It will give me rank 3 only. This feels like that. It feels like that. So let's check it. And honestly I don't know. I framed this example 2 days back and today I'm solving it. So what I feel is that this is what I would have framed the example in a manner that it should give me 0 nullity. So R3 minus 2R1. This is something that I need to do. I am just trying to get the row echelon form. So if I get the row echelon form, then I will be able to comment on the rank, right? And if I know the rank, then I will be able to know the nullity as well. So 0, minus 1 and minus 1, right? Okay, thrice you need to subtract. So this will become minus 2, right? And here twice you need to subtract. So this will become 0, and here twice of this, and this will become minus 1. Yes, this is in the row echelon form only. You can simply interchange, no? Now you simply interchange R2 with R3. R2 with R3 you interchange. So you will get the row echelon form only. One, 2, 1. Then okay. Why I am interchanging? This is already in the row echelon form, no? What I am doing? This is already in the row echelon form, right? What does that mean? Rank of A is coming out to be 3. What does that mean? Nullity of A is coming out to be 0. So from here what you can say, sir, if I make this equation Ax equals to 0, then I know that I can have two kind of solution, unique solution or infinite solution. But unique solution I will get, what is the order here? 3 cross 3. So if my rank is 3, then I will get unique solution. If my rank is less than 3, then I will get infinite solution. So if it is 3, that means I will get unique solution, and that solution would be nothing but 0, 0, 0. And here this condition is not even achieved. If this condition would have been achieved, then I needed to solve in this manner, that x1, x2, x3 I would have taken, and then I would have solved it. But here what I saw is that I felt like that the rank might be 3 here. That means nullity might be 0 here. That means there is only one possible vector in the null space, and in the null space only one element would be there, and that element would be nothing but 0, 0, 0. Now someone would say, sir, what should be the dimension then? What dimension I will say? What is the dimension? So for this you cannot define the dimension. You cannot say, sir, dimension is 0, or you cannot say dimension is 1. Someone would say that, sir, at least one linearly independent vector is there, no? So I would say dimension is 1. But I told you 0, 0, 0 is never a matter of concern. When I talk about the null space, I never considered 0, 0, 0, because it is pretty obvious that if I am having a matrix A and I multiply this with the 0, 0, 0 vector, then for sure all the vectors will go down to 0 only. Basically in this matrix A there are 3 vectors, vector 1, vector 2 and vector 3. And if these 3 vectors are multiplied with 0, 0, 0 vector, then they will surely go out to 0 only, no? It is pretty obvious. right? So that's why 0, 0, 0 is never considered in the dimension. So if they are asking the dimension, no, in the examination, if they are asking the dimension of null space, dimension of a span of null space, then they will make sure that they will give nullity at least one. They will never give full rank matrix, because if they know if full rank matrix is given, then there is only one possible element in the null space, and that element will be 0, 0, 0. So here dimension will not even be asked. If dimension is asked, then for sure you will see that nullity will be greater than equals to 1. Either it will be 1 or greater than or equals to 1. This kind of question could be asked, that find out the dimension of null space of A. So what you will do, sir, I need to calculate the rank first. What I will do, I will calculate the rank first. And what is the order here? Sir, order is 3 cross 4. So maximum rank that could come out to be 3. But sir, let's see what rank I can get. And R2 I am going to replace with R2 minus R1, right? Oh, sorry. What I am doing? R2 is being replaced with R2 minus 2R1, and R3 will be replaced with R3 minus 3R1, right? So 2, 3, 4, 1. So twice of this, and here twice of this. What will be the twice of this? Minus 6 you will get, and here minus 1 you will get. Is that clear to you? 8, right? 8, 2, and here minus 1. Yes. And here thrice of this I need to subtract. So this will be 0, this will be also 0, and this will also be 0, and this will also be minus 2. And again, it is not a good example, right? Because the rank is coming out to be 3. Rank is coming out to be 3. It is a good example. Okay, it is surely a good example. Rank is coming out to be 3, but number of variables are 4, right? Rank is coming out to be 3, no? Thrice you subtracted, thrice you subtracted, thrice you subtracted, and minus 2. What is the rank? So rank of matrix A we are getting as 3. Is it a full rank matrix? Absolutely not. What is the nullity? Nullity is the number of variables minus the rank. Nullity is 1. So what will be the dimension of null space? That would be 1. Is that clear to you? That means there will be one independent vector. What I mean to say is that in the null space of A, in the null space of A, there will be one linearly independent vector. One linearly independent vector. What does that mean? Dimension of span of null space of A will be 1. They usually forget this word span. Okay, ideally it should be written. Ideally it should be written that you are finding the dimension. Dimension of what? Dimension of span of null space of A. But they will write down this kind of language only. In the examination, 2 to 3 times this question has been asked, and every time they have put up a dimension of null space. But actually the actual wording would be dimension of a span of null space. That would be equal to the nullity. You find out the nullity, it came out to be 1. So it will be 1 dimensional. And you can check out as well. There will be only one free variable. You can check on your own. Do you want me to check? Okay, so let's try doing it. What we are going to do, we are going to find out Ax equals to 0. What does that mean? That means I will take up this equation, which I guess I have already copied, and then multiply with the solution vector, which will be x1, x2, x3, x4. Why is that so? Because the order here is 3 cross 4. So here I will get 4 cross 1. So x1, x2, x3, x4, and that should be equated to 0. So now let me know one thing. If I solve this equation, or I solve this particular equation, which is this one, are both of them same? Yes, sir. You have given this concept when we were studying about linear equations. This concept you have given, that either you solve this equation or you solve this particular equation, both are absolutely same. Both are absolutely same, right? So here when I write down 0, that simply means This is what I'm writing now. Okay, so 2x1 plus 3x2 plus 4x3 plus x4 equals to 0, minus 6x3 minus x4 equals to 0, minus 2. I hope you understand. 2x1 plus 3x2 plus 4x3 plus x4 equals to 0, 0x1 0x2, then minus 6x3 minus x4 equals to 0, then 0 0 0 minus 2x4 equals to 0. So from here what you are getting, sir, x4 is coming out to be 0. x4 is coming out to be 0. Okay, so if x4 is coming out to be 0, so if you put x4 here, then x3 is also coming out to be 0. x3 and x4 both are coming out to be 0, right? If x3 is 0, x4 is 0, then what you can see, if this is equation 1, x3 x4 both are 0, then you can directly see that 2x1 plus 3x2 will be equals to 0. Now you have one free variable. Let's just say I say that x1 equals to c1, then what will be x2? x2 will be nothing but minus 2 c1 divided by 3. Say yes or no? If I say x1 equals to c1, then x2 will be nothing but minus 2 c1 divided by 3. So what is the solution vector that you are getting? The solution vector that we are getting is x1, x2, x3, x4, that will be equals to what? This is c1 minus 2 c1 by 3, 0 and 0. That will be equivalent to what? c1 I can take common. Here it will be 1, here it will be minus 2 by 3, here it will be 0, here it will be 0. So this is one linearly independent vector I will have. Okay, other could be multiply with 2 here, so it will become 2 minus 4 by 3, 0, 0, then 3 minus 4 by 3, 0, 0, in that manner. So this is the one linearly independent vector I will have. In the null space, I will have these kind of linearly independent vectors. Is that clear to you or not? Is the concept clear to you? In the examination, they will ask simple kind of question, find out the dimension of null space of A. But if they are asking good theoretical question in that manner that nullity of A is less than n, then the dimension of null space of A will be one dimensional or two dimensional. In that manner, if good theoretical question they are asking, then also you will be able to solve. If I just told you that dimension of null space means nullity of A, then you would not be able to solve. But now your concepts are crystal clear. Say yes or no, right? Yeah, so this concept is done. Okay, null space of A, that concept is done. Next, what we need to consider, we need to discuss about AB equals to 0. Matrix A multiply with matrix B, that will give you 0 result. So what we can conclude about A and B? First case, we are considering that A and B both are square matrices. So considering A and B both are square matrices, you need A multiply with B equals to 0. So what you can conclude about A and B, that we need to see. But before that, you solve a division question. You don't need to make any conclusion, just solve it. You need to multiply A and B. Multiply A with B. What answer you are getting? 1, 0, 1. 1, 0, 1. Minus 1 and minus 1. This is answer you are getting, right? A multiply with B. 1 multiply with 1, 0. 1 multiply with 0, 0. 1 multiply with 1, 1, 1, 0. Minus 1 multiply with 1, minus 1. Minus 1 multiply with 0, 0. Then minus 1 multiply with 1, minus 1. Minus 1 multiply with 0, 0. So this is the answer you are getting. Understandable? Or you can put a minus sign here. Okay, otherwise you will be getting confused. So this will become minus, oh, let it be. Forget about it. So this is the answer you are getting. And here also you do the multiplication. A multiply with B. What you are getting? 1, 1, 0. 2 minus 2, 0. 1 minus 1, 0. Then 2 minus 2, 0. So here you are getting 0. So what is the conclusion we are making from here? As of now, nothing, but later on we will come back to this slide. But you just see A matrix was given, B matrix was given, AB we got, A was given, B was given, AB we got. What is the conclusion, sir? We will see that, but have some patience. Okay, let's discuss AB equals to 0. A and B both are square matrices. So what I am saying, if A multiply with B is going to be 0, then can I say that if A is 0 and B could be anything, then also result would be 0. Any matrix multiply with the null matrix would give you 0 matrix. Or if can I say if A is anything but B is 0, then also the result would be 0. Right? Any matrix multiply with the null matrix will give you 0 result. Or what I can say, if both are 0, 0, then also the result is 0. Right? Both 0 multiply with 0, then also result would be 0. It is pretty obvious, no? If A into B is 0, then first chance that I have is either A is 0, B is non-zero. B could be anything, but A is a null matrix. So A is a null matrix multiply with B matrix, that will be null matrix only. A matrix multiply with null matrix, that will be null matrix only. Null matrix multiply with null matrix will be null matrix only. So these are the three cases we have written. Sir, then what is to discuss here, sir? There is something interesting as well. So these three cases are there. If A and B both are null matrices, what does that mean? A is a null matrix, B is also a null matrix. Then what is your AB? AB will be simply null matrix multiply with null matrix, result will be null matrix only. If A is a null matrix and B is not a null matrix, then what will happen? A into B I need to do null matrix multiply with non-null matrix, which is B, which I don't know, null matrix only. And if A is not a null matrix and B is a null matrix, then A is as it is, B is a null matrix. Understandable? Three results are there. But is it necessary that to get AB equals to 0, one of these cases has to be there? Is it necessary? Is it a null matrix? Is it a null matrix? No. Is it a null matrix? No. What is the A into B? What A into B is giving you? Null matrix. Non-null giving you, multiplication is giving you null. Both are square matrices as well. So three cases, sir, you have taken. One of them is a null matrix or both of them is a null matrix, then surely I will get null matrix only. But sir, if both of them are non-null, is it null? No. What is the meaning of null matrix? All element 0. So is it a null matrix? No. Is it a null matrix? No. Still I am getting 0. So next case is A and B both are non-null matrix. What does that mean? A is also not null and B is also not null. Understandable? This is the case. This is given. This is given. What I need to do? I need to make A into B equals to 0. This is matrix A. Basically I am writing matrix A into B. This I am writing as AB. This is something I need to make 0. What do I need to make 0? AB equals to 0 I need to make. Now what I do? I multiply with A inverse. What do I do? I multiply with A inverse. Pre-multiplication I do. Left side multiplication. Okay. So pre-multiplication I am doing with A inverse. Pre-multiplication with A inverse. Okay. Just listen to the derivation very carefully. Like whatever that I am doing, just you need to listen to very carefully. Okay. So pre-multiplication with A inverse I am doing. Pre-multiplication with A inverse. So A inverse multiply with A will be identity matrix. Identity matrix multiply with B. Now A inverse multiply with 0. What you will get? 0 only. Now identity matrix multiply with B. What you are getting? B is a null matrix. You started from here that both cannot be null matrix. Listen to the words very carefully. Both cannot be null matrices, but you are getting the result that B is a null matrix. That means this is not acceptable, no. You are starting with the condition that B, you are starting with the condition, which condition you are starting with? That B cannot be a null matrix, but eventually you are getting the result that B is a null matrix. So where I am going wrong? Is there anything wrong in that derivation? That can I multiply AB equals to 0 is given, then can I multiply with A inverse? Yes, you can multiply with A inverse. Then B is coming out to be a null matrix. What is wrong here? Sir, when you wrote down this step, when you wrote down this particular step, here what did you assume? Here the assumption was, here there was an assumption. What was the assumption? Here the assumption was that A inverse exists. Here you made an assumption that A inverse is existing. If A inverse is existing, what does that mean? That this is non-zero. So if your determinant is non-zero, then there is nothing wrong with the derivation. But you are saying that this derivation should be wrong. This should be wrong. This particular derivation should be wrong. Why it should be wrong? Because your condition is that B should not be equals to 0. So that means you are saying that this should be wrong. This should not happen. This should not happen. If you don't want it to happen, that means you don't want this step to happen. This step should not come. This step should not be true. And if you don't want this step to be true, what does that mean? This step should not be true. If you don't want this step to be true, what does that mean? That means A inverse should not exist. Because if A inverse is not existing, then this step you cannot even do. So A inverse should not exist. And if A inverse is not existing, what does that mean? That means its determinant should be 0. Basically, AB equals to 0 is given. This is the condition I need to get. AB equals to 0 is given. I started multiplying. Here I multiply with A inverse. What I got to know? That B equals to 0. Okay, that means B is a null matrix. B is a null matrix. B is a null matrix. But this is not my required scenario. Not required. Not desired. This is not my desired scenario. My desired scenario is that B should not be a null matrix. B should not be a null matrix. That means this derivation should not be true. If you don't want this derivation to be true, if you want this derivation to be false, then this pre-multiplication with A inverse should not be possible. And if you want A inverse should not be possible, what does that mean? That means the determinant of A has to be 0. So if I am saying that A is not a null matrix, B is not a null matrix, still AB equals to 0, then determinant of A has to be 0. But there will be condition on determinant of B as well. Similar condition could be there, no? What I am saying again, that A is not a null matrix and B is not a null matrix. Okay? But still A into B equals to 0. Now what I am doing? Post multiplication with the B inverse. With the B inverse. So if I do the post multiplication with B inverse, this is A, this is B, then B inverse here, then this is 0, multiply with B inverse. So 0 multiply with B inverse will be 0, B multiply with B inverse will give you I, so A is coming out to be 0. Again, not desired, not desired, not desired, not desired. So basically you started from this step, I want this step, then what I did, I thought that let's multiply with B inverse. Then you go to know that A is coming out to be 0. But sir, it is not even required. We started with this condition only, no? That means this step should not be possible. This step should not be possible. Should not be possible. Should not be possible. If you don't want this step to be possible, or if you want this step to be impossible, that means B should not be reversible, or determinant of B should be 0. What is the conclusion? Given that AB equals to 0, also or better I should write down, given that A is a non-null matrix and B is a non-null matrix and multiplication of A and B is 0. So if one of them are null matrix, then it was pretty obvious that they will be 0 only. But if both are non-null matrix, still their multiplication is 0. That means what does this conclude? That determinant of A should also be 0 and determinant of B should also be 0, or what you can say, A and B both should be non-invertible. Non-invertible. Because if they are invertible, both should be non-invertible. Because sir, if they are invertible, then what will happen is that I will be multiplying A inverse here, then B will come out to be 0, or I will be multiplying B inverse here, then A will come out to be 0. So both should be non-invertible, then only it is possible. And here is the example. This example we took. Let me know what was here determinant of A. So determinant of A was 0. Minus 1, determinant of A was 0. What was determinant of B? So that was also 0. So yes, A was non-null, B was non-null. Determinant of A was 0, determinant of B was 0. That's why AB equals to 0. Is that clear to you or not? Is this conclusion clear to you or not? This question is coming in the examination. It is a MSQ problem. Give me the correct answer. Think about it. Think about it. Think about it. MSQ problem. Give me the correct answer. I want the correct answer. Have some patience and give me the correct answer. A and B both are non-zero square matrices. Non-zero square matrices of the same order. Which of the following statements are true? If AB equals to 0, then determinant of A and determinant of B is 0. Proven. Non-null. AB equals to 0, then determinant of A and determinant of B equals to 0. If determinant of A and determinant of B is 0, then AB equals to 0. Sir, determinant of A, determinant of B equals to 0. Both are non-null. Sir, this condition is given. This condition is given. Then, sir, this condition we will get. Notice the arrow. Arrow is coming downward. That means if A non-null, B non-null, AB equals to 0 is given, then this is true. When did I say that inverse is also true? When did I say that you can go from here to here? When did I say so? What is the determinant here? Determinant of A. What is the determinant? -1, 0. What is the determinant here? 0. Determinant of A is 0. Determinant of B is 0. Is AB equals to 0? Is it a null matrix? No. So listen to the statement very carefully. What is the statement? It is given that A is non-null. It is given that A is non-null and B is non-null and AB equals to 0. Then determinant of A and determinant of B will be 0. If A is non-null, B is non-null and determinant of A and B is 0, then AB would be equals to 0. It is not necessary. So statement otherwise is not true, right? You cannot go from down to up to down. A is 0, B is 0 and AB equals to 0. Sorry, A is non-zero, B is non-zero and AB equals to 0. That means determinant of A and determinant of B should be 0. So opposite is not true. Always take care of this thing. Okay, always take care of this thing. And if AB equals to 0, then determinant of A equals to 0 or determinant of A equals to 0 or determinant of B equals to 0. No, and should be there. No, and because both of the conditions should be satisfied. If I say that B is invertible, if I am saying that B is invertible, if I am saying B is invertible, then A will come out to be null matrix, which is not given. A has to be non-null. Or if I say A is invertible, if A is invertible, then B will come out to be null matrix, but it has to be non-null. That means both should be satisfied. This should also be satisfied and this should also be satisfied. That's why there is an and. Okay, not or, and. Both of the conditions should be satisfied. So this is also wrong. Then if AB equals to 0, then exactly one of them should be exactly one of determinant of A or determinant of B is 0. No, both are 0. Okay, not exactly. Both are 0. Okay, both should be 0. So only A is correct. Although it is a MSQ, but only one of the option is correct, not two. In examination, it may happen, no. In MSQ problems, one option may also be correct. So this may feel like that, sir, this will be a tougher question, but it is a very easy question. The only conclusion you need to remember is that if A is non-null and B is non-null and AB equals to 0 is given, then determinant of A should be non-zero and determinant of B should be non-zero. That's it. There is no other concept apart from this. This was given for square matrices. What if there is not a square matrix? What is given? A is a non-zero matrix of order m cross n and B is a non-zero column vector of n cross 1. Given that m is greater than n and also AB equals to 0, which of the following statements are true for rank of A? Think about it. Think about it and give me the answer. Okay, you need to think on your own and you need to solve this question. It is a MCQ only. Which of the following statement would be true? Okay, I am pausing the video. I will take a break and then I will come back. Hint is AX equals to 0. This is the hint. Hint is AX equals to 0. Okay, that's it. So try solving this question. I will take a break and then I will come back. Yeah, welcome back. So did you try this question? Matrix A is having an order of m cross n. Matrix A is having an order of m cross n where m is greater than n. So what does that mean? What could be the maximum value of rank of A? What could be the maximum value? The minimum value of mn, right? Minimum of mn. So maximum value could be n only. What does that mean? That means rank of A would be less than or equals to n, but again, can it ever be equals to n? It could be equals to n. So basically this option is gone, this option is also gone. But can it be equals to n or not? This is the question that I am asking. So what is given? AB equals to 0 is given. B is a column vector of n cross 1. Column vector of n cross 1. Isn't it like vector x only? I am assuming B is vector x. So isn't it like Ax equals to 0? Yes sir, Ax equals to 0. So Ax equals to 0 solution, do you know? Absolutely sir. For the solution of Ax equals to 0, we have two conditions. That this is equals to n and this is not equals to n. Here I don't know what will be the value of x, but sir, in this condition, there will be a unique solution. There will be a unique solution, and in this case, I already know what will be my x, which is equals to b. Sir, that will be all 0. That means, sir, if Ax is equals to 0, then if x is all 0 vector, then the rank of A has to be equals to n. But what is given? It is a non-zero vector. What does that mean? That means B cannot be equals to 0. What does that mean? Rank of A cannot be equals to n. That means it has to be less than n. Till this point, you are so much comfortable. We have discussed Ax equals to 0 so much time that this question should have been solved. If you are not able to solve it, then I cannot do anything. This should have been solved now. Okay, we have discussed about homogeneous equation, non-homogeneous equation. We have discussed about vector space, null space, everything we have discussed. Till this point, these kind of questions, this much intuition you should click. Okay, Ax equals to 0, you need to think. Okay, Ax equals to 0, then sir, non-zero vector is mentioned. That means this condition cannot be possible. That means this condition has to be possible. That's it. So rank of A is less than n. In the examination, how they will ask this question? A be a non-zero matrix of order 4 cross 3, B be a non-zero column vector of 3 cross 1. Given that AB equals to 0, what all are the possible value of rank of A? First option 1, second option 2, third option 3, fourth option 4. Then you will say only 1 and 2 are possible. Rank of A cannot be equals to 3. Why it cannot be equals to 3? It cannot be equals to the number of column. It cannot be equals to 3. Why is that so? Because sir, if it is equals to 3, if it is equals to the number of columns, what does that mean? That means there will be only one solution, which will be the 0 vector. But they are saying that it is not a 0 vector. What does that mean? This condition is not possible. So this condition is only possible. So rank of A is less than n. Understandable? Let's go to the next question. This question as well, you will feel like that, sir, what is given? But you know everything about this question. Every single thing you already know. So C1, C2, Cn are scalar. These are scalar. C1, C2, they are scalar. Scalar means they are some constant number. Some constant number they are. It could be 1, 2, 3, whatever it is. And A1, A2, An, they are the column vectors. They are column vectors. What does that mean? That means they are column vectors of dimension n. You can see r to the power n. They are the column vectors of dimension n. That means A1 could be somewhat like this. At 1, 2, dot, 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 in that manner. So what will be the order? N cross 1. N rows would be there, 1 column is there. Similarly, A2 could also be something different. Like let's just say it is 2, 3, dot, 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 in that manner, order would be n cross 1. Understandable? Now what is given? Ci into Ai equals to 0, I going from 1 to n. What does that mean? They are saying that C1 into A1 plus C2 into A2, C3 into A3 and Cn into An equals to 0, where all these vectors are not all 0. That means they are simultaneously not 0. So from here, what you can understand? Have you studied somewhat like this? Lambda 1 A1 vector plus lambda 2 A2 vector plus lambda 3 A3 vector. If that is equals to 0, what does that mean? That means A1, A2, dot, 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 An are linearly dependent. So similarly here, A1, these are the vectors only, no? A1, A2, dot, 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 An are linearly dependent. Now, how many linear independent vectors are there? How many linear dependent vectors are there? I don't know, but I can say that they are framing a set of linearly independent vectors. Is that understandable to you or not? They are framing a set of linearly dependent vectors. Is that clear to you? Right? Now, if I frame a matrix A, what do? I frame a matrix A. In this matrix A, I am putting A1, A2, A3, dot, 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 An as column. So first let me know what will be the order n cross n, because there will be n rows, n columns. Understandable? N cross 1, n cross 1, n cross 1. So n rows, n column. Can you let me know one thing, that what will be the rank of A? I am saying that it will be surely less than n. Can you say it? Why it is surely less than n? Because sir, they are the set of linearly dependent vectors, no? So at least one vector will be linearly dependent. Is that clear to you? If I am saying that a1, a2, dot 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 an are set of linearly dependent vectors. If this is the line a1, a2, dot 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 an are set of linearly dependent vectors, what does that mean? The meaning is at least one vector is linearly dependent. What does that mean? That means the rank of A would come out to be less than n. Is that clear to you or not? Now they are talking about the equation Ax equals to B. They are talking about the equation Ax equals to B. And now what is B? What is B? B is summation I going from 1 to n. So your B is nothing but A1 plus A2 plus A3 dot 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 An. So what was your A1? This was your A1. This was a matrix. This was also a matrix. A3 was also a matrix. And dot 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 An was also a matrix. So eventually it will also turn out to be a matrix only. Eventually this will also turn out to be a matrix only. Is that clear to you? This will turn out to be a matrix of order n cross 1. They were matrix of order n cross 1, matrix of order n cross 1, matrix of order n cross 1, matrix of order n cross 1. One thing I can surely say, that this matrix B will be linearly depending on A1, A2, dot 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 An. Why is that so? Because of this line. It is pretty obvious, no? B is depending on A1, A2, A3, dot 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 An. Now Ax equals to B is the condition, right? I know there could be three scenarios: no solution, unique solution, and infinite solution. What is the condition of no solution? Rank of A would not be equals to rank of A augmented B. What is the condition of right? What is the condition of a unique solution? That rank of A should be equals to rank of A augmented B, and that should be equals to the number of variables. That should be equals to n. That should be equals to the number of columns of this matrix A. This matrix A is n cross n, right? This matrix A will become n cross n. So that should be equals to n. So it should be equals to n. And here they should be equal but less than n. Now one thing I have already seen, that rank of A is not equals to n. Rank of A is less than n. One thing I have already seen, that rank of A is less than n. This I have already seen. That means this condition is gone. Unique solution condition is gone, right? Unique solution condition is gone. Now you are left with, sir, either this condition could be possible or this condition could be possible. What I mean to say is that let's just say rank of A is n minus 1. Then someone can say that, sir, rank of B is n. If this is the condition, then what will happen? There will be rank of A is not equals to rank of, sorry, not rank of B, rank of A augmented B, sorry. If this is the condition is achieved, then someone will say that no solution. And if this is the condition that is achieved, then someone will say infinitely many solution. So two possible conditions are there. So which of the condition would be possible? Can you think of it? Can you think of making A augmented B matrix? Let's make A augmented B matrix. So how your A augmented B matrix would look like? If I make the A augmented B matrix, then this is how it will look like. This is A1, this is A2, then An would come up, and then here A1 plus A2 dot 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 An would come up. This is the scenario, right? This is the scenario. So this much part is of A, and this is your A augmented B. Now I am assuming that let A1 is depending, let vector A1 is dependent. Only if vector A1 is dependent, rest all are independent. So what does that mean? What will be the rank of A? Can anyone tell? If A1 is dependent, one column is dependent, rest all are linearly independent. What does that mean? Rank of A will be n minus 1. Do you agree to this point? Just let me know one thing. How many columns are there in A augmented B? How many columns are there in A augmented B? Sir, n column plus 1 column. So in A augmented B, total n plus 1 columns are there. total n plus 1 columns are there. In A augmented B, total n plus 1 columns are there. Out of that, I surely know that this is dependent. A1 is dependent. A1 is dependent, and for sure this is dependent as well, because it is depending on A1 plus A2 plus A3 plus AN. So it is surely depending on these guys. So this is also dependent. What I have given is that I have assumed A1 is dependent. But this is for sure dependent, no? This column is for sure dependent. It is for sure dependent. There is no doubt about it. Expression is saying A1 plus A2 plus A3 plus dot 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 AN. So it is surely depending. And this I have assumed to be depending. Right? Why I have assumed to be depending? Why this is dependent? Because this condition is given. C1 dot AI, C1 A1, C2 A2. So I am assuming A1 is dependent, rest all are independent. Okay, so I assumed A1 to be dependent, then rank of A came out to be n minus 1. Now here for A augmented B, total columns are n plus 1. Total columns are n plus 1. Out of that, 2 are linearly independent. Total columns are n plus 1. Out of that, 2 are linearly dependent. What does that mean? Total n minus 1 linearly independent columns are there. Total n minus 1 linearly independent columns are there. Here also total n minus 1. That means rank of A is coming out to be rank of A augmented B. That is coming out to be equals to n minus 1, which is less than n. What does that mean? There will be infinite solution. All these questions are very difficult to solve for a lot of people, but not for you, because you have absolutely all concept clear. You will just see this particular thing. That means you will get to know that this column is already depending. So rank of A augmented B, one column is already gone, and from the side of A, one column is already gone. From the side of A, one more column is gone. What does that mean? That means rank of A would be equal to rank of A augmented B only, because in A augmented B, one extra column would be there, which is already dependent. That means rank of A augmented B will always be equal to rank of A only. What does that mean? There will be infinite solutions. Say yes or no. Is that clear to you? Understandable? All good. Okay. So these kind of questions also you will be able to solve. This is a very good question. But again, if our intuitions are clear, we will just write down whatever that is given, and based on that, everything will click to us. There is nothing difficult in these kind of problems. Let's go to the next question. Yeah, so basically we need to solve this particular problem. But for solving these problems, this question and I guess this problem as well. So for solving these two problems, you require some concept of dot product. Already a lot of guys would know it, but still let's revise. So A dot B, what is A dot B? Sir, you know that I cap will be multiplied with I cap. So sir, this you have already taught and we already know it as well. So sir, what's new? So this A dot B is equal to something else as well. That is equals to the determinant of A multiplied with determinant of B, cos of angle between them, this angle, internal angle. Okay. So if I do A dot B, then determinant of A multiply with determinant of determinant means magnitude. Here I should say magnitude. Magnitude of A multiply with magnitude of B multiply with cos of angle between them. What will be your magnitude of A? Magnitude of A will be nothing but sir A1 square plus A2 square plus A3 square multiply with B square, that would be B1 square plus B2 square plus B3 square multiply with the cos of angle between them, which is cos theta. Sir, anti-clockwise angle I should take or clockwise? Any angle you take. Whether you take clockwise or anti-clockwise, anything you take. But it should be the internal angle. Okay. So that will be the answer you will be getting. A dot B. So A dot B equivalent to two things, this thing and this particular thing. Understandable? Let's solve this question. U and V are two vectors in R2. What does that mean? U and V are two-dimensional vectors. U and V are two-dimensional real vector. 2D real vector. Right? And what is this? Magnitude of U is twice of magnitude of V. Okay. So can I assume a two-dimensional vector on my own? Basically, we need to find out the value of alpha. So anything you can assume, no? Any vector you can assume. Let's just say I am assuming vector V as I cap plus j cap. So what is the magnitude here? That is under root 2. Now you want magnitude of U to be twice of this. So I am taking 2 under root 2. Okay. So I am assuming vector U to be minus 2i cap minus 2j cap. Sir, why did you take negative sign? Basically, I am assuming it to be minus twice of I plus j cap. Right? What I assumed it, basically I need the twice magnitude, no? So what I assumed, minus 2 I cap plus j cap. That could be written as minus 2 I cap minus 2 j cap. Sir, I could have also assumed it, but sir, why did you assume the negative sign here? You will understand when we solve the problem. Why did you take the negative sign? Now what they are asking, there is another vector w, that is given as u plus alpha v. What is u? U is minus 2 I cap minus 2 j cap. What will be alpha v? That will be alpha I cap plus alpha j cap. So it could be written as alpha minus 2 I cap plus alpha minus 2 j cap. So this is your vector w. So vector w you are having, okay, and vector v we are having, and vector u we are having. Now what this is saying, you need to find the value of alpha such that this vector w is bisecting the angle between u and v. W bisects the angle between u and v. Now if I would have taken a positive sign here, if my v was I cap plus j cap and u was 2 I cap plus 2 j cap, then I cap plus j cap would have been in this direction. Let's make it. So I cap plus j cap, it would have been in this direction, and 2 I cap plus 2 j cap would also have been in this direction only, no? Because what is I cap plus j cap? One here, this is I cap plus j cap. What is 2 I cap plus 2 j cap? That will be this vector. So they will be in the same direction. So what will be the angle between them? That will be 0 degree. And what is the bisecting of 0 degree? That will be 0 degree only, no? So I will not be able to solve the problem in a good manner. If I want to bisect, then what I did, I assumed it in the negative direction. So if I have assumed it in the negative direction, then what will happen? This was your I cap plus j cap. This was your I cap plus j cap. What will be your minus 2 I cap minus 2 j cap? Minus 2 I cap minus 2 j cap would be somewhere here. Minus 2 I cap minus 2 j cap would be somewhere here. So what is the angle between them? So the angle between them is 180 degree. And what will be the bisect? This will be the bisect. Is that clear? So let me make the diagram. If we make the diagram, you will understand that how did I assume these vectors in a careful manner. So what I did was, I made this kind of diagram that I know that one vector would be here, which will be I cap plus j cap. It is I cap plus j cap, right? And another vector would be somewhere here, which would be minus 2 I cap minus 2 j cap. So this was your vector u, and sir this was your vector v. Now you are getting another vector w somewhere in between. So another vector w which will be perfectly bisecting the angle. What does that mean? That means, sir, this angle will be 90 degree. That means, sir, this angle will be 90 degree, and this angle will also be 90 degree. This is your vector w. So what does that mean? The angle between w and u is 90 degree. What does that mean? W dot u would come out to be magnitude of w multiply with magnitude of u multiply with cos of angle between them. What is that? 90 degree. What is the value of cos 90? That is 0. So if two vectors are orthogonal, then their dot product is 0. That we already know. So intelligently I have made w as orthogonal to u. So what is w dot u now? W dot u. What is your w vector? So w vector is 1 minus 2 alpha I cap. No, sorry. Alpha minus 2 I cap. Alpha minus 2 I cap and alpha minus 2 j cap. Alpha minus 2 I cap and alpha minus 2 j cap. Alpha minus 2 I cap and alpha minus 2 j cap. And what is u vector? U vector is nothing but I cap plus j cap. So you know that dot product should be equivalent to 0. What is their dot product? Alpha minus 2 multiply with 1 plus alpha minus 2 multiply with 1, and that should be equivalent to 0. So from here what do you see? Alpha is coming out to be nothing but 2. There you go. That's the solution. That's the answer. Okay. So this is how intelligently we need to solve these kind of problems. Is that clear? Whatever that was given, we just wrote down that condition, and intelligently we thought, first I will take 2 I cap plus 2 j cap only. Then I would know that, sir, angle is 0 degree. How it will bisect, right? So that will be a problem for me. Understandable? So for that, even if I take 0 degree, bisecting would be, w will be making 0 degree angle, and then you will have to take magnitudes and all. So calculation will become complex. So basically let's take 180 degree angle between them. If angle is 180 degree, then W will be somewhere in between, making an angle of 90 degree. If it is making an angle of 90 degree, that means their dot product would be 0, and from there I can get the value of alpha, which is coming out to be 2. Okay, let's go to the next one. This question, A and B dot product, A and B belonging to R cube, not R cube, R3 we should say. A and B belonging to R3. That means both are the vectors only. Vector A is there, which could be A1 I cap, A2 j cap, A3 k cap, and then vector B would be there, B1 I cap, B2 j cap, B3 k cap, right? Now what the determinant of this will show, like what will be A dot A, vector A dot vector A, what that would be, A1 multiplied with A1, that would become A1 square, A2 square, A3 square, B dot. Basically they did not make the vector sign, but here there is vector, you should understand. Okay, if they are writing the bold letter, that means it is vector by default, so they might not make the sign, you should understand on your own. Okay, let's call this as this is nothing but magnitude A square, no, and this is nothing but magnitude of B square. Understandable? This is nothing but magnitude of A square, this is nothing but magnitude of B square. So let's call magnitude of A as alpha and magnitude of B as beta, right? So what I am supposed to calculate, I am supposed to calculate A dot A, which is the magnitude A square, that means alpha square. What is A dot B? That will be the magnitude of A. What is A dot B? A dot B will be nothing but magnitude of A multiply with magnitude of B multiply with cos of angle between them. So magnitude of A is alpha, magnitude of B is beta, cos of angle between them. So alpha into beta cos theta. What is B dot A? Same, alpha into beta cos theta. And what is B dot D? B dot B is magnitude of B square, magnitude of B is beta square, so this will become beta square. So what will be the determinant here? So that will come out to be alpha square beta square minus alpha beta cos theta, alpha beta cos theta, so that will become alpha square beta square cos square theta. So I can take alpha square beta square common, 1 minus cos square theta. Okay, so sir, this value will always be positive. Alpha square will also be positive, beta square will also be positive. Alpha is already the magnitude, no, so it will be positive. Beta is already the magnitude, it will be positive. Then you are doing the square, it will be positive. 1 minus cos square theta is already positive, because what is the maximum value of cos? That is 1. 1 minus 1 could be 0. What is the minimum value of cos? That is minus 1. Minus 1 whole square, that will also be 1, so that will also be 0. So basically this has to be this particular determinant. Let's just call this determinant as neta. Okay, this determinant I am calling as neta. So neta is coming out to be alpha square beta square 1 minus cos square theta, which will be greater than or equals to 0. This is the condition we are getting. Okay, now what they are saying, if A and B are linearly dependent, what is the meaning of A and B being linearly dependent? Let's just say this is vector A and this is your vector A, okay, and this is your vector B. So if A and B are linearly dependent, that means the angle between them would be equals to 0 degree. Theta would be equals to 0 degree. If they are linearly dependent, what is the meaning of linearly dependent? Alpha is already taken, no? So let's take some other value, gamma. A is equivalent to gamma of B vector, right? A vector equivalent to gamma of B vector. That means the angle between them will be 0 degree. If you put 0 degree here, what you will get? Cos 0 is 1, 1 minus 1 is 0. So it is equals to 0 if A and B are linearly dependent. If A and B are linearly dependent, then what will happen? If A and B are linearly dependent, then angle between them will become 0. So this will become cos 0. This will also become cos 0. Cos 0 is 1. So this will become alpha square beta square minus alpha beta. So this will become alpha square beta square. What is the answer you are getting? 0. So if A and B are linearly dependent, the angle between them is 0. So cos 0 is 1. So alpha square dot beta square minus alpha square beta square. What is the answer? 0 you will get. So it is equals to 0 if A and B are linearly dependent. And if A and B are linearly independent, then if A and B are linearly independent, then it will be positive. Why is that so? This will be positive. If they are linearly independent, that means A would not be equivalent to this scenario. That means theta will not be equals to 0 degree. And for any other theta, let's just say theta is 35 degree. So you put cos 35, this value will always come out to be positive. Yes sir, understandable? So both are true. I hope it is clear to you. Okay, the angle between both of them would be equals to 0 degree, or it could be equals to 180 degree as well. If they are linearly dependent, it could be 180 degree as well. Let's just say this is vector A and this is vector B. So what I can write down here, vector A is equivalent to minus vector B. So what is the angle between them? Angle is 180 degree. Here vector A, here vector B is twice of vector A. So angle is 0 degree. So either the angle would be 0 or it would be 180 degree. If you put 180 here as well, then also it is coming out to be 0 only. So if they are linearly dependent, then angle could be either 0 or 180 degree. If you put 180 degree, this is coming out to be 0. If you put 0, this is also coming out to be 0. And apart from that, it will always be positive. That's it. Understandable? Let's go to the next one. A be a 2 cross 2 orthogonal matrix. X is this vector, which is a real column vector. Find out the relation between these two guys. What is the meaning of this? Basically, this is your A, which is A, B, C, D. But it is an orthogonal matrix. Always remember, it is a orthogonal matrix. And this is your vector X, which is x1, x2. Now they are saying that you multiply A with X. What you are going to get? A, this is 2 cross 2. This is 2 cross 1. So what will be the order you will be getting? 2 cross 1 only. So A multiply with x1. What you are going to get? A multiply with x1, B multiply with x2. A multiply with x1, B multiply with x2. C multiply with x1, D multiply with x2. So what you are going to get? 2 cross 1. So what will be the magnitude you will be getting? Magnitude you will be getting is, basically this is the new vector, no? So what will be the magnitude? This square plus this square. If you are not able to understand, then can I write down Ax as, this is a vector only, can I write down Ax as Ax1 plus Bx2 I cap plus Cx1 Dx2 j cap. So what will be its magnitude? Under root Ax1 plus Bx2 whole square plus Cx1 Dx2 whole square. That would be A square x1 square plus B square x2 square plus, basically this is A plus B whole square. So A square plus B square plus 2AB. So 2AB x1 x2. In the under root only it is going on. So C square x1 square plus D square x2 square 2 CD x1 x2. So what you are going to get? What you are going to get? A square plus C square x1 square plus B square plus D square x2 square plus 2 AB plus CD x1 x2. Right? This is the scenario you are getting. Understandable? Now if it is the orthogonal matrix, you know one thing, that A square plus B square should be equals to 1. C square plus D square should also be equals to 1. Along with that, AC plus BD would be equals to 0 and AB plus CD would be equals to 0. If it is an orthogonal matrix, can you write down all these things? A square plus B square equals to 1, C square plus D square equals to 1, AC plus BD equals to 0, AB plus CD equals to 0. This we have already seen in the basics. So yes, along with that, column wise also you can write down, no? This is row wise I wrote down. A square plus B square, C square plus D square. Along with that, you can write down column wise as well, that A square plus C square would be equals to 1 and B square plus D square would be equals to 1. So all these things you can write down. Say yes or no. If it is orthogonal. A square plus B square equals to 1, C square plus D square equals to 1, A square plus C square equals to 1, B square plus D square equals to 1. So what will be the value of A square plus C square? That will be 1. This value is nothing but 1. What is the value of B square plus D square? That is also 1. And what is the value of AB plus CD? AB plus CD, that is 0. So what you are getting? This particular thing. This is 1, this is 1, this is 0. So what you are getting? It is coming out to be A square plus C square is 1, B square plus D square is 1. So it is coming out to be x1 square plus x2 square. So magnitude of Ax is coming out to be x1 square plus x2 square, and magnitude of x is coming out to be what will be the magnitude of x? Simply it would be under root x1 square, because this is written as x1 I cap and this is written as x2 j cap. Basically x could be written as x1 I cap plus x2 j cap. So if you calculate the magnitude, what it would come out to be? x1 square plus x2 square only. So what you can sense here, what you can understand, what I can understand is that it is coming out to be x1 square plus x2 square only. So magnitude of Ax is coming out to be magnitude of x. So magnitude of Ax is coming out to be nothing but magnitude of x only. So all these kind of calculation, as of now it might feel like, sir, it is too much, but in the examination very easily you will be able to do. Write down A, write down x, just think about it. A, B, C, D, you already know all these conclusions, but I will start from here. I will get to know that a square plus b square, a square plus c square is coming out to be, that will be equals to 1. B square plus d square, that will be equals to 1. AB plus CD, that would be equals to 0. So it is simply coming out to be the magnitude of x only. I will be able to click on the option. Other thing also is very interesting. Can you think of it? Magnitude of B is equivalent to what? If you remember, what B transpose into B represents? Magnitude of B square, right? So if I need this particular thing, what that would be equivalent to? A into x transpose, A into x transpose multiply with Ax, what that would represent? Say yes or no, right? So similarly, magnitude of Ax square would be Ax transpose dot Ax. Do you remember it? If there is a vector B, its magnitude will be B transpose into B. And what will be the trace of B into B transpose? So that would also be magnitude of B square. Do you remember this thing or not? I hope you remember it. I told you we can derive it as well, and in the basics we have seen it. Not in the basics of vector we saw it, right? So what I can write down? Ax transpose, it could be written as x transpose into A dot Ax. X transpose into X transpose into A transpose. A into B transpose has the property of B transpose into A transpose. So A into X transpose could be written as X transpose into A transpose, multiply with A, multiply with X. Now A transpose into A, what that would be equivalent to? A transpose into A. A transpose into A. A is a orthogonal matrix. What is the meaning of orthogonal matrix? A transpose into A should be equivalent to I. So A transpose into A should be equivalent to I, multiply with X. I multiply with X will be X. This is X transpose only. So it is coming out to be X transpose into X. What is X transpose into X? That is this thing only. So what did you get to know? This and this is coming out to be equal. So magnitude of Ax square is coming out to be magnitude of X square. So from here what you can conclude? Magnitude of Ax is coming out to be magnitude of X. There you go. Someone would say that, sir, why you did not take the negative sign? Basically, if A square equals to B square, then sir, there could be two possible answers, that A equals to B and A equals to minus B, right? Two possible answers are there, no? So sir, why you ignored this case? Because they are positive value, no? This is also positive, this is also positive. Basically, 2 equals to minus 2 square. What I mean to say is that, let's just say I'm writing down x square equals to 4. X square equals to 4. So what is the value of x? So you will say, sir, there are two possible answers, x equals to 2, x equals to minus 2. But if I say x is positive, then only this answer is possible, no? Why you wrote down plus 2 and minus 2? Because you know that 4 could be written as plus minus 2 whole square, right? So from here x could be either equals to plus a or it could be equals to minus a. So similarly here someone would say that, sir, why a negative sign? Why not negative sign? Negative sign can also be possible, no? But they are magnitude, no? This is also positive, this is also positive. So positive value has to be equals to positive value only, right? So magnitude of Ax would be equals to magnitude of x. Understandable? So this question is also done. We are just solving the problems, okay? This question we solved, this question we solved. These are good level of questions based on vectors. So here mathematics is also involved. Along with that, your linear algebra concept is also involved, okay? So basic questions these are not related with anything that vector space or anything. Basically these kind of questions are framed, then how we will solve it, what kind of intuition or what kind of Here it is intuition, here it is mathematics. So it's up to you whether you want to do with respect to mathematics or with respect to the intuition. If it is clicking to you, it is very difficult, no? The magnitude of ax and magnitude of x. So will it click to you that sir ax transpose dot ax we do, then x transpose dot a transpose into a would be equals to I. So if it is clicking to you in the examination, then it is good. Then within 30 seconds you will be able to tell the answer. But here you need to do some calculation. It will take 2 to 3 minutes. This will take 30 seconds. Just like this question. P is a matrix A1, A2, 2 cross 2 matrix it is. What does that mean? A1 and A2 are column vectors. It is given A1 and A2 are column vectors. Understandable? And now when you make the matrix P, so here also some element would come, here also some element would come, and it will come out to be 2 cross 2 matrix. What does that mean? This has to be 2 cross 1 and this also has to be 2 cross 1, right? Because here 2 element, this will be 2 cross 2. So understood, this would be 2 cross 1, this would also be 2 cross 1. Understandable? And what is P inverse? P inverse is given as B1 transpose, B2 transpose, and they are saying that B1 and B2 are row vectors. So if P is of order 2 cross 2, then P inverse will also be order of 2 cross 2 only. And what would be B1 transpose? They are row vector. So there has to be 2 columns, right? There has to be 2 columns. So this will be 1 cross 2, 1 row, 2 column, 1 row, 2 column. And what will be B2 transpose? 1 row and 2 column. So 1 cross 2. Then you need to comment on B1 transpose into A and so on. So this P inverse is given, P is given. One thing I already know. What do I know? That P into P transpose, P into P inverse would be equals to P inverse into P, and that would be equals to I. And both are 2 cross 2 matrix, then I know that it will be equivalent to 1 0 0 1. So at the end of the day, by the multiplication I need 2 cross 2 matrix. Is that clear to you? Now what is my matrix P? P is your this matrix A1, A1, A2, A1, A2, and this is my P inverse, which is B1 transpose, B2 transpose. If you multiply P with P inverse, what you will do? A1 multiply, basically this is row and this is column. So how will you do the multiplication? Row with respect to column, right? So this row will be multiplied with this column. So A1 into B1 transpose plus A2 into B2 transpose. Only one element I will get. Although sir it is not a one element, there will be 4 elements. But if I just simply multiply P with P transpose, and it feels like that I am getting only one element. But what if I multiplied P inverse? Basically what is the order here? Although I know that it is 2 cross 2, but here how many rows I can see? Only one row I can see. And how many columns I can see? 2 columns I see. Someone would say that sir, here there are 2 rows. I know that. It is actually a 2 cross 2 matrix. I know it is actually a 2 cross 2 matrix. But if you see from this scenario A1, A2, directly you treat them as one vector. So 1 cross 2 and here 2 cross 1. So if you multiply both of them, eventually you will get 1 cross 1 only, no? But what if I take P inverse first? That this is my P inverse. And then this is my vector P, which is A1, A2. So here I can sense 2 rows, 1 column, and here I can sense 1 row, 2 column. If I do the multiplication, P inverse into P, what I am getting? Row will be multiplied with this column. So what you will get? B1 transpose multiplied with this column. So in this column only one element is there. So B1 transpose into A1. Then B1 transpose into A2. This row will be multiplied with this column now. So B1 transpose into A2. Then B2 transpose into A1 and B2 transpose into A2. That should be equivalent to 1 0 0 1. So you can see that B1 transpose into A1, B1 transpose into A1 is coming out to be B2 transpose into A2, that is coming out to be 1, and B1 transpose into A2 is coming out to be B2 transpose into A1, that is coming out to be 0. That's it. Okay, all 4 correct. All 4 correct. So how intelligently we answered this question, is that understandable to you? Otherwise you could have taken any kind of vector, no? In your mind, take any kind of vector. Take a random A1, A2 value. take a random b1 b2 value, take any random vector and solve it. Okay, basically you assume any matrix P. This is your matrix P, right? Which is, let's just say 1 2 and 2 1 I have assumed. Can I find out P inverse? Yes sir, P inverse will come out to be, you know that they will be interchanged and their sign will be interchanged. Now can you let me know what is B1 transpose? Yes sir, B1 transpose is 1 minus 2. What is A1? A1 is nothing but 1 and 2, right? If you multiply B1 transpose with A, what you will get? 1 into 1 minus 2 into 2. ये क्या हो गया भाई? Oh sorry, I forgot to divide by them. Like basically let's solve what could be method 2. Okay, let's solve the method 2. I'm giving you another method. So what could be the method 2? So method 2 would be that I assumed any random matrix which is matrix P. That matrix P I have assumed as 2 2 1 and 3. Understandable? So what will be my P inverse? Sir, P inverse will be nothing but both of them interchanged, and here negative sign multiplied with 1 by its determinant. What is the determinant of P? 4 minus 3, that is 1. So as per the given question, P was A1 A2. So this was your A1, this was your A2, right? And B1 transpose, B2 transpose. So this was your B1 transpose and this was your B2 transpose. So as per the given question, this was your A1, which is 2 3. This was your A2, which was 1 2. This was your B1 transpose, 2 minus 1, 4 minus 3. And this was your B2 transpose, which was minus 3 2. Understandable? Now what you need to do? A1 into B1 transpose. A1 into B1 transpose. So 2 3 multiply with 2 minus 1. I don't think this is what we need to do. We need to do B1 transpose into A1, right? B1 transpose into A1. Yes, B1 transpose into A1. So we need to do B1 transpose into A1. So what is B1 transpose? B1 transpose is nothing but 2 minus 1. And what is A? That is 2 and 3. So 2 multiplied with 2 will give me 4. Minus 1 multiplied with 3 minus 3. What is the answer I am getting? 1. So any random example you take, no? B2 transpose into A2. What answer you will get? Minus 3 into 1 will give you minus 3. 2 into 2 will give you 4. What is the answer you are getting? 1. Then B1 transpose into A2 you do. So 2 multiplied with 1 will give you 2. Minus 1 multiplied with 2 will give you minus 2. What is the answer you are getting? 0. B2 transpose into A1. Minus 3 multiplied with 2, minus 6. 2 multiplied with 3, plus 6. What is the answer you are getting? 0. There you go. So from here also you can make the conclusion that these options are matching and you will be able to match the option. Is that clear? So this was the method 2, which feels like a easier method. Here there is some intuitions are involved, that how would I think that here only one element I will get, but I need multiple elements. So this is how I can think of it. Understandable? So both of the method, any of the method might click. In the examination, I will be more comfortable in taking the values. Here also in the last question as well, most of the guys would be doing in this scenario only. That's our A, B, C, D directly. Let's take all these conditions I already know and I will be able to get the answer. Most of the guys. But what if here 7 cross 7 was written? Then what you would do? Can you take 7 cross 7 matrix? If 7 cross 7 is written, no, then understand that this will be a standard. Then you will have to understand that even if I take 2 cross 2 as well, then also something standard I will get. Okay, so let's just say in the examination 7 cross 7 is written and this method is not clicking to you. Then what you should do in the examination hall? That do it with 2 cross 2. Whatever the result that you are getting, the same result would be applicable for 7 cross 7 as well in 99% cases. Okay, so if you feel like that, sir, I need to take the values with respect to values, I will do. Then do it with respect to the values. If it is clicking to you, then from here you can conclude that it is applicable for any n cross n, right? It is applicable for any n cross n method, that this would always be equal for any n cross n orthogonal matrix. They will be always equal for any n cross n matrix, right? Here as well, like if values are clicking to you, then do it with respect to values. Otherwise, do it somewhat like this. Let's go to the next one. Now here what you will do, find the rank of A. Aij is given, value of I is greater than 1, value of I is greater than or equals to 1, and value of j is less than equals to 1, and it is given that n is greater than or equals to 3. Find the rank of A. If I take n equals to 3, if I take n equals to 3, then what will be the first option? It will become, first option will be 0 only, second option will be 1 only, third option will be 3 minus 1, which is 2, and fourth option will be 3. So that means in all the options I am getting different answer. So let's just take n equals to 3 and solve this question. Let's just take n equals to 3 and solve this question, right? So whatever the rank I will get, based on that I will click on the option. Is that clear to you? So let's design our matrix A. What will be our matrix A? Matrix A is nothing but Aij, where Aij equals to I into j. What does that mean? What will be your 3 cross 3 matrix, right? Because order I have taken as 3. So it will be a 3 cross 3 matrix, which will look somewhat like this. So I into j, 1 into 1, this is A11, right? A11, A12, A13. So 1 into 1, 1 into 2, 1 into 3. Then A21, A22, A23. So 2 into 1, 2 into 2, 2 into 3. Then A31, A32, A33. So 3 into 1, 3 into 2, and 3 into 3. Directly you can see here is that I can apply the transformations, R2 being replaced with R2 minus 2 R1, R3 being replaced with R3 minus 3 R1, right? So this is 1, 2, 3, 0, 0, 0, 0, 0, 0, 3 cross 3. So this is after the transformation. You can directly see that rank of A is coming out to be 1. So which is the option? This will be the option. And from here you would have understood, no, even if I would have taken 4 cross 4, then this kind of matrix I would be getting. Aij is there, no? So 1, 1, 1, 2, 1, 3, 1 into 4 will be 4 only. Then 2 into 1, 2 into 2, 2 into 3, then this will be A34, sorry, A24, A24. So that will come out to be 8. That will come out to be 8. Then 3, 1, 3, 2, 3, 3, 3, 4, then 4, 1, 4, 2, 4, 3, and 4, 4. And here as well you know that if you apply the transformation, rank of A will come out to be 1 only. Rank of A is coming out to be 1 only. Always rank of A will simply do the twice of row 1 and subtract it from row 2. Do the thrice of row 1, subtract it from row 2. Do the 4 times of row 1, subtract it from row 4. What you are getting? 1, 2, 3, 4, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So rank of 1 is coming out to be 1. Option B. Understandable? Solve this question. V1, V2 belonging to R3, linearly independent vectors. Linearly independent vectors. Okay. B is A into A transpose. Find out the rank of B. What do you need to find out? Rank of A into A transpose. Do you remember this property that rank of A into A transpose would be equals to rank of A? So they are simply asking the rank of A. What will be the rank of A? What is matrix A? R3. That means A, B, C, D, E, F. What is the order? 3 rows, 2 columns. Both are independent. Both are independent. Right? So what will be the rank of A? Both are independent. Rank of A would be 2. So this would be equals to 2. There you go. Along with that, do you remember this property or not? I am writing down this property. I hope you remember that rank of AB would be less than or equals to minimum of rank of A and rank of B. And rank of AB would be greater than or equals to rank of A plus rank of B minus n. In the miscellaneous properties, right? Or I said not so important properties. In not so important properties, we studied this particular thing. And what is n here? N is nothing but A is m cross n and B is n cross B. So this is your n, right? So do you remember this particular thing? Using this scenario as well, you can solve it. Answer will come out to be 2. But let's solve this particular question. So V1, V2 linearly independent belonging to R3. V3, V4 linearly independent belonging to R3. They are framing the matrix A and B. So this is your matrix A, V1, V2. Directly let me know, 2 vectors are there, both are linearly independent. What will be the rank of A? Sir, it will come out to be 2 only. B, 2 linearly independent vectors. V1, V3 transpose, like basically they are the column vector, no? So V3 transpose they are saying. That means in row wise you need to write down. Whether you write down row wise or you write down column wise, rank will not change, right? So if I write down in this manner, so what will be the rank here? So rank of B will also be 2 only. What I am making? I am making C, which is AB. What you need to find out? You need to find out the rank of C, which is equals to rank of AB. So you know that, sir, rank of AB would be less than or equals to minimum of rank of A, rank of B. What is the minimum value between 2 and 2? That will be 2 only. And sir, it would be greater than or equals to rank of A, which is 2, plus rank of B, which is 2, minus what? This will be a 2 cross 2 matrix. This will also be a 2 cross 2 matrix. No, sorry guys. This is R3, no? So this will be a 3 cross 2 matrix. 3 cross 2 matrix. And V3 transpose, this will be a 2 cross 3 matrix. So here there will be 2 rows and 3 columns. So this will be a 2 cross 3 matrix. So what is the common value here? That is 2. So minus 2. Understandable? Like this kind of matrix A would be there. No, V1, V2. V1, V2. V1, V2 belonging to R3. So A, B, C, D, E, F. R3 means 3 dimension would be there. So A, B, C, D, E, F. Both are independent of each other. Rank is 2. Order is 3 cross 2. And simply here you would get to know that order would be 2 cross 3. Or if you want to do the multiplication, if you are doing A dot B, that means it has to be 2, no? And I only care about the common guy. Which is 2 here. Right? So minus 2. So what you are getting? That rank of AB should be greater than or equals to 4 minus 2, that is 2. So rank of AB should be less than or equals to 2. Rank of AB should be greater than or equals to 2. So what is the possible answer? Answer is 2 only. Right? Because what you are getting is that rank of AB should be greater than or equals to 2 and it should be less than or equals to 2. That means only possible answer is 2. Understandable? Well and good. Simple, very simple. Just remember this property. Sometimes question can be asked in this manner, or remember this property as well. What was the property? That's a rank of A would be equals to rank of A inverse if it is existing, would be equals to rank of A conjugate, would be equals to rank of A transpose, would be equals to rank of A into A transpose, would be equals to rank of A into A conjugate. So both of the properties we have revised, nothing else. Okay. What about this question? Try solving it. M to the power 4 equals to I, where I is the identity matrix. M is not equals to I, M square is not equals to I, M to the power 3 is not equals to I. For any natural number k, what will be the value of M inverse? You need to find out the value of M inverse. So M to the power 4 equals to I is given. Right? On both of the side, I am multiplying with M inverse. What is M to the power 4? So it is M multiply with M cube. And now on both of the side, I am multiplying with M inverse. So here also I have multiply with M inverse. And here also I have multiplied with M inverse. So what you are getting? So this will become I. M inverse into M will be I. I multiply with M cube, you will get M cube only. And here you will get M inverse. So what is the answer you are getting? That's our M inverse is coming out to be M cube. Now let's see one thing. M inverse is coming out to be M cube. So this is your M cube. Now can I write down M cube into I? Right? Any matrix could be multiplied with the identity matrix. Can I write down this as M to the power 4? Because M to the power 4 is nothing but I only. Or can I write down this as M to the power 4 to the power k? Because M to the power 4 is I. Now M to the power 4 to the power k will be equals to I to the power k. And if you remember, I to the power 2 or I to the power 3 or any power, it will be always equals to I only. Or I to the power k, that will always be equals to I. So M to the power 4 into k, that will be equals to I only. So what you are getting? M to the power 4 into k, 4k plus 3. So this is what your M inverse is coming out to be. There you go. So what is the answer? 4k plus 3. How will you think of it? In the examination, if you need to think of it, k is a natural number, no? So let's take k equals to 1. Just put k equals to 1 here. So this will become M to the power 5, M to the power 6, M to the power 7, M to the power 4. So how will you solve it? First one will become M to the power 5. Natural number. What is the meaning of natural number? 1, 2, 3, 4, 5, 6, 7, 8, whatever it is. So take k equals to 1. So option 1 will become M to the power 5. This will become M to the power 6. This will M to the power 7. And this will become M to the power 4. Now you know that this is coming equals to I. But your M inverse equals to M cube. Now this is M to the power 5. So M to the power 5 could be written as M to the power 4 into M. M to the power 4 is I only. So it is equivalent to M. This will be equivalent to M square. and this will be equivalent to m cube. So which one is the answer that is matching? M cube. That means this option is matching. So option C is correct. This is how you can think in the examination hall. So all these are good question I am picking up. Okay. Decent level of problems you will be able to do, but only good question I am picking up, that how you will think in the examination. So in brief level, somewhere here you can write down that I will put k equals to 1 here. So m to the power 5, m to the power 6, m to the power 7 and m to the power 4. So m to the power 7 will be m to the power 4 multiplied with m to the power 3. M to the power 4 is I only, so it will become m to the power 3 only. So m inverse is m to the power 3. A is P, Q, R, S. B is this. Rank of A is given n. Find out the rank of B. So what will click in the examination hall? In the examination hall, let's just say I am not able to think what it is. So I can take random values. I need to make rank of A equals to n. And what is A? Let's just say nothing is clicking to me. P, Q, R, S was given, right? So I took some random values. P I have taken as 2, Q minus 1 and 2. What is the rank of A? Rank of A is 2. You can do it on your own. Rank of A is coming out to be 2, which is equals to n. Now can you find out matrix B? What is matrix B? Matrix B is P square plus Q square. So P square plus Q square, 2 square plus 1 square, that will be 5. Then R square plus S square, 1 square plus 2 square, that will be 5. R square plus S square, R square plus S square. Then PR plus QS, PR plus QS, PR plus QS. 2 into minus 1, minus 2, 2 into 1, 2, 0. Here also PR plus QS, that is also 0. This is the matrix we are getting. What is the rank here? It is in the row echelon form only. So rank of B is also coming out to be 2, which is equals to n only. So which option is matching? This option is matching. That's it. This will be the correct answer. This is how I can think. Otherwise, if someone can think of it, then B is nothing but A into A transpose. Okay. Do the multiplication of A with A transpose. What you will get? You will get B matrix only. If it is clicking to you, what will be B? What is A? P, Q, R, S. What is A transpose? P, Q, R, S. So P into P, P square, Q into Q, Q square. Then P into R, and then Q into S. PR, QS. Then R into P, then Q into S. So PR into QS. Then R into R, R square plus S square. So B is nothing but A into A transpose. There is no shortcut, nothing. It will have to click. If it is clicking, then it will click. If it doesn't click, then it doesn't click. Understandable? So B is A into A transpose. Now you know one thing, that rank of A will always be equals to rank of A into A transpose, and that will be equals to n. So option C is correct. Otherwise, you take the random values, then also you will be able to get the answer. Eventually, we need to get the correct answer. That's it. In tuitions and all, in the examination, this will also give you +1, and this will also give you +1. Understandable? What about this question? Do it very quickly, within seconds. So what people will do? 2 into 1, 2, 9 into 4, minus 36, 5 into 7, 35. So 37 minus 36, so answer is 1. Let's move to the next question. Wrong. You noticed, you did not even notice what you did here. This was 3 cross 1, and this is 1 cross 3. So if you multiply both of them, the resultant will be 3 cross 3. So find out the resultant. No, you did the multiplication, you just did the element wise multiplication and you added them, right? So in a hurry, this kind of error can happen. That's why I took this question, that if you try to do it within 30 seconds, then this kind of thing will happen. So row will be multiplied with column. So 2 multiply with 1, 2. Then again row will be multiplied with column. 2 multiply with, here it will be 18. Then 2 multiply with 5, 10. Then minus 4 will be multiplied with column. Minus 4. Then 36. Minus 36, sorry. Then minus 20. Right? And then 7 will be multiplied 7 and 35. What you can sense here? These are proportional to each other. Actually, these are proportional to each other only. Okay? They are proportional to each other. Since they are proportional to each other, then determinant of A is coming out to be 0. Determinant of A is coming out to be 0. Okay? Let's solve it by another way. What do we do? This is a matrix P, okay? And this is a matrix Q. Can you tell me the rank of matrix P? Rank of matrix P. Sir, it is 3 cross 1. Rank, maximum rank could be 1 only. And yes, sir, rank is 1. What could be the rank of Q? That is also 1. So isn't it PQ? So what will be the rank of PQ? Sir, it would be greater than or equals to minimum value of P and Q. What is the minimum value of P and Q? That is 1. And what will be rank of PQ? So that would be less than or equals to rank of P, which is 1, plus rank of Q, which is 1, minus the common 1. So rank of PQ will be less than or equals to 1. What does that mean? Here you are saying that it should be greater than or equals to 1. Here you are saying that it should be less than or equals to 1. That means, sir, rank of PQ is coming out to be, rank of PQ is coming out to be 1. That is equals to rank of A. So rank of A is coming out to be 1. And rank of A is a 3 cross 3 matrix whose rank is coming out to be 1. What does that mean? That means determinant of A would be 0. So I know all these things will not click in the examination hall, but what if in the examination hall this question was asked that this is A given, find out the rank of A. Then you would have find out this matrix and then you can calculate the rank, right? Not very tough. You can calculate the rank, it will come out to be 1 only. But if you think in this manner, then you can think in this manner as well. It's up to you. What will click in the examination hall, that's up to you. Okay, if this is clicking, then it's up to you, right? My job is to teach you different methods. Now PQR is a, P is a 4 cross 2 matrix, Q is a 2 cross 4 matrix, R is a 4 cross 1 matrix. Find the minimum number of scalar multiplication required to compute PQR. P is M cross N and Q is N cross P. So what will be the number of multiplication required? Number of multiplication required. This we proved as well, we saw the intuition as well, and then we wrote down that number of multiplications required was M into N into P. M into N, this is common, M into N into P. Now you need to do PQR. Okay, this is your P. Do we have the space? No, we don't have the space. So I will have to add a page. Okay, let's do it on the next page only. So this is your P, which is 4 cross 2. Then your Q, which is 2 cross 4. And then it is R, which is 4 cross 1. So what student would do? That, sir, first let's multiply P into Q. Let's just say multiplication of P into Q is giving me X. So what will be the order of X? That will be, sir, 4 cross 4. And then, sir, I will get Q into X. And then eventually, sir, I will get them multiplication. Let's just say PQR is giving me S. That will be 4 cross 1. So this is how I will do the multiplication. Sir, from here to here I came. That means I multiply with P with Q. So how many multiplication would be required? How many multiplication would be required? Sir, 4 into 2 into 4. So multiplication required would be 4 into 2 into 4. Sir, 32 multiplication will be required here. Right? And sir, when I did this multiplication, so how many multiplication would be required, sir? 4 into 4 into 1. So sir, total 16 multiplication are required. So sir, total number of multiplication required is multiplication. Total number of multiplication required is, sir, 48. 32 plus 16, sir. 32 plus 16, sir, 48. And there you go, sir. I will be getting 1 mark. But congratulations, you are getting 0 marks. Why is that, sir? Minimum number. Find out the minimum number of multiplication required. So is it necessary that PQR could be done here? Like PQR you need to do. So is it necessary that you do the PQR calculation in this manner only? No. Someone will say that, sir, I will do the PQR calculation in this manner. That first I will multiply QR and then I will multiply with P. Say yes or no? 2 ways are there, no? So let's check that out. This is your P, which is 4 cross 2. This is your Q, which is 2 cross 4. And this is your R. You checked only one case, no? You forgot to check this case. Let's check this case. So when you do the multiplication, let's just say you are getting the matrix Y, which will be of order 2 cross 1. And then you will multiply with the matrix P, which will be of order 4 cross 2. And then when you multiply them, you will get S matrix, which will be of 4 cross 1. Right? So when you came from here to here, how many multiplication were required? 2 cross 4, 4 cross 1. So 2 cross 4 cross 1. So multiplication required were 8. Right? And when you came from here to here, how many multiplication were required? 4 cross 2, 2 cross 1. That means 4 cross 2 cross 1. 4 cross 2, 2 cross 1. So 4 cross 2 cross 1, matrix multiplication required was 8. Not matrix multiplication, total number of multiplication required were 8. So here 8, here 8. So total multiplication required would be, total number of multiplication required would be 8 plus 8. Answer would be 16. There you go. 16 multiplication would be required. So what will be the answer? Answer will be 16. Okay, not 48. This will be wrong. Answer would be 16. Okay, so always you need to check both of the cases. So minimum number of multiplication they are asking 16. Maximum would have been 48. Find out this question. This is the last question. So tell the answer of this question. A, B, C, D equals to I. You need to find out the B inverse. So what is given? A, B, C, D equals to I. I need to get B inverse. That means I need B somewhere. Somehow I need to get B. So if I multiply A by A inverse here, what I need to do is that I am multiplying by A inverse. I am multiplying by A inverse. So A inverse into I will get. So A inverse into A will become I. So this will become BCD and this is A inverse. Similarly, then I will multiply with D inverse. Right? So post multiplication of D inverse I am doing. So D into D inverse will become I. So this is coming out to be BC into A inverse into D inverse. Then I will have to multiply with C inverse. So post multiplication of C inverse I am doing. So C into C inverse will become I. So this is B I am getting. This is B I am getting. Now if I need to get, this is your B, right? You have got B. You have got B, right? So if I have got B, which is A inverse, D inverse, C inverse. Now I need B inverse. So what I will do? A inverse, D inverse, C inverse, then take inverse of that. And do you remember this property? PQR inverse would be equals to R inverse, Q inverse, P inverse. So similarly, A inverse, D inverse, C inverse would be equals to C inverse and then inverse, D inverse, then inverse, and A inverse, then inverse. So inverse of inverse, again C matrix. -1 into -1 will be 1 only. Inverse of inverse, D. Inverse of inverse, E. So this is your B inverse that is coming out to be, which will be equivalent to CDA. That's it. Okay. So this is done. Now our last topic is left, which is eigenvalue and eigenvector. Understandable? So that we will see next. I hope you are enjoying till this point. In this lecture, first we studied about null space, then we studied about AB equals to 0, and then we solved some question. It was related with everything that we have studied, right? Mostly questions are based on basics of matrix and determinant, basics. This is also basics of matrix and determinant. This is also basics of matrix and determinants, and some were good questions. So based on that, we have seen all those problems. Okay, well and good. So let's meet in the next lecture. There we will study about eigenvalues and eigenvectors. I hope you are enjoying linear algebra. Thank you very much. Let's meet in the next lecture.